Hi, if you guys are familiar with Sierra Chart, you would know that most of the time it only runs on one or two CPU cores at a time, and study functions only run on one CPU core. Now, I ran into a bit of code that I wrote that was taking a little bit long to execute, and I tried to obviously improve that by writing better code. But what I also did was I used that particular code block as an experiment to see if I could achieve multi-threading for doing a calculation in a Sierra chart study function. And I did succeed in doing that now, and I'm going to show you that right now. So um, just a little bit of the code here, even though I'm not really going to go through it, but basically there's a particular function. In this case, this is the function. It's called change tested lines color, and there's a workload associated with this for the number of lines that need to get their color changed and their length changed on the chart. So when you're working with daily charts or historical charts that have a large number of days on the chart, because my code does a lot of sequential writes one after another, it takes long to execute, and it basically blocks the main thread of the software until all of them are completed, because the study functions only run on one thread. So just to show you, I press F5 to go into chart settings, and I'll show you the days to load for the historical chart data type. 10,000 days loaded on the chart, and this is Apple stock, so there's a lot of days here on this chart. And in my study here named VT supply demand zones, I added an input setting called number of CPU cores to use, and I'm going to put it to 1 just to show you how long it takes to execute this code block just on one CPU. So I pressed it, it freezes the main thread. There's the thread working, running at 5,000 something megahertz. This is a beefy machine I'm on here, it's a laptop. And that's done, and this is how long it took. It took 10,000 milliseconds to execute that, and the number of drawings was 1884. Now what I'm going to do is show you the multi-core workload. So doing the same thing, I'm going to go into the settings and show you how you can defer that workload onto multiple threads. So one thing that's interesting in my input is that I can put a really high number here. It's only going to go as high as the number of CPU cores on my machine, but you should never use this anyways, because you'll probably get diminishing returns. At least I found I got diminishing returns above about 12 or 14 cores. So let's do 4 cores now and run the same workload and have a look at the processors running. So I press that, there's the 4 cores running. And we take a 10-second workload down to 4.3 seconds. That's pretty good, not too bad. All right, and let's increase it one more time to 14 threads. And we take it down to 2.7 seconds. Very good, very good. And just to remind you guys, I'm iterating over every single bar on this chart. There's more than 10,000 days loaded on this chart, and we're calculating over all of them. And obviously the code could be improved, because the reason why it's taking long is because there's definitely a bottleneck in the code block itself that's being executed. But I did want to show this nonetheless, because I thought it was interesting that I could use multiple cores to execute the study function rather than always having one core. I mean, if you can use 2 cores, it's better than 1. Thank you for watching.